In this lesson, we're going to talk about how to find the sum of an infinite geometric series. So let's say if you get a problem that looks like this. So you want to find the sum of this series, and we have the geometric sequence 1/2 raised to the n. So if we were to write out the terms of the sequence is an is equal to 1/2 raised to the n. The first term, a sub 1, that's going to be 1/2 to the first power. So if we just write out all the terms, it's going to be 1/2. The second term, if you plug in 2 for n, it's going to be 1 squared over 2 squared, which is 1/4. The third term will be 1 over 8, and then 1 over 16, and so forth. So you got to multiply by 1/2 to get the successive term. So the next term is going to be 1 over 32. And whenever you multiply by a common ratio, then you're going to generate a geometric sequence. Now, the sum of each of these terms will produce a geometric series. So this represents the sum starting from, in this case, the 0 term to the infinite term. We said that a sub 1 is 1/2. A sub 0 is 1. So what we're going to do is basically add up all the terms starting from a sub 0. So 1 plus 1/2 plus 1/4 plus 1/8 plus 1 over 16, all the way till n reaches infinity. So how can we find the sum of the infinite geometric series? It turns out that there's a formula that you can use, and it works if the common ratio is less than 1, which it is. The common ratio is 1/2. So let me give you the formula. So let's say if you have a geometric series in the form of a times r raised to the n. So the sum is going to be a divided by 1 minus r. So we can see that r is 1/2. But now, what is a? A is the number in front of r. So if we don't see a number, it's a 1. So a is 1, r is 1/2. Now, 1 minus 1/2 is 1/2. And 1 divided by 1/2 is 2. So the sum of this infinite geometric series is equal to 2. Now, if you take your calculator and add these values, notice what's going to happen. So 1 plus 1 over 2, that's 1.5 as a decimal, plus 1 over 4, that's 1.75, plus 1 over 8, that's 1.875, plus 1 over 16, that's going to be 1.9375, and then the next one plus 1 over 32, that's 1.96875, and then plus 1 over 64, 1.984375. So if you keep adding this geometric series, you're going to get closer and closer to 2. But you never really quite reach 2, but it just gets closer and closer. It approaches 2. Now let's work on another example. So feel free to pause the video and try this problem. So let's say we want to find the sum of another infinite geometric series. So where n starts from 0 and it goes all the way to infinity. And so the sequence is going to be 4 times 2 over 3 raised to the n. Go ahead and try that. So first, we need to identify a and r. So what's a and r in this problem? So we can see that a is 4, and r is the stuff that's raised to the n power, so that's 2 over 3. So using the formula, the infinite sum is going to be a divided by 1 minus r. So a is 4, r is 2/3. So to simplify this complex fraction, let's multiply the top and the bottom by 3. So 4 times 3 is 12. 3 times 1 is 3, and then 3 times 2/3, the 3's will cancel, giving us -2. Now 3 minus 2 is 1, and 12 divided by 1 is 12. So the sum of this infinite geometric series is 12. That's the answer.